What's going on, guys? It's Cooper Codes, and in this video we have a really interesting project. We are going to be building a Q&A chatbot API which allows us to use our own custom data. So whether you're trying to make a customer service agent or just make a chatbot for your own data, this video should cover everything you need to know. This tutorial is going to cover everything. We are going to build a documents database to store our embeddings. We are going to use Supabase Edge functions, which allow us to scale our API to infinity, and we are going to connect to the OpenAI API in the backend. If you're looking to work with chatbots and understand how to use custom data alongside your chatbot, this is the video for you. So we can get started by taking a look at the overall system. And I know this is a lot of information, but we're going to step through it one thing at a time. The first thing we're going to do is we are going to have a Supabase Edge function, which pretty much is just like an API endpoint. And we can ask it a certain question, for example, who is Cooper Codes? In the backend, we are then going to build a system that gets us the relevant information to that specific question. For example, we might have some documents stored like Cooper Codes is a YouTuber, Cooper Codes likes music, or Cooper Codes has 5.3K subscribers. In a second, I'm going to talk about these strings and the system we are going to build so we can get relevant data to a specific question. Since this asked who is Cooper Codes and it's supplying a bunch of Cooper Codes related data, that's on purpose, and we are going to make a system behind that. And so once we get our relevant information, we can then ask ChatGPT our question with the information in the prompt. An example of this might be this full prompt here, where we say who is Cooper Codes, and then we supply some relevant info that ChatGPT gets access to. This is especially important because ChatGPT has no information on who Cooper Codes is. I'm a relatively new channel, and so it never really scraped the internet for who I am. And so because we have the custom information in our prompt here, ChatGPT can give us a response like, Cooper Codes is a YouTuber who likes music, and he currently has 5.3K subscribers. All of that data is coming from the system we are going to build. A quick example of this working in real time is I'm going to run a simple server. Don't worry about what this is for now, but I'm looking at our specific endpoint we are going to build, and then I'm querying for, does Cooper Codes have a website? ChatGPT by default doesn't know if I have a website or not. But once we run this code, it's then going to give us a response saying, yes, Cooper Codes has a website called coopercodes.com. And this is some information that I've passed into my documents, which we can talk about more right now. When understanding specific information in our system, we need to understand what are embeddings. You can see here is a great example where we have the cat chases the mouse and the kitten hunts rodents. The embedding of these statements is where they're located on this graph. And you'll see two similar statements are going to be closer to each other. This is why we have the I like ham sandwiches and it's very far away from everyone else. And so for the sake of this tutorial, a very simple way of understanding it is embeddings are a way for us to compare strings and see if they are similar. And I'm talking about embeddings because when you have your own information, it has to be turned into an embedding. Let's take a look at this next example. We have a very kind of abstract idea of three different statements that are all really close to each other because they're all talking about Cooper Codes. So Cooper Codes is cool, Cooper Codes listens to music, and Cooper Codes is a programmer. Because they're all talking about a similar subject, they're going to be close to each other. And so if we bring in some new information and create the embedding for a question like, who is Cooper Codes, it's going to be stored close to these other statements. And a basic way of understanding this is there are ways to see how similar is this question compared to the data in our system. And so if we were to ask who is Cooper Codes, it could then connect to all of our different data here. And so because we have these three relevant data points to, who is Cooper Codes, we can then pass these over to ChatGPT. And so this brings up an important question. How do we create embeddings? So embeddings kind of happen in a simple three-step process. We can take our initial string we want to turn into an embedding and then pass it into an OpenAI embedding model. It's going to take that string and return a unique vector that represents the embedding for our input string. And so when the embedding model returns a unique vector, what it's talking about is literally an array with a bunch of different values like this. This is how the large language model understands certain statements and understands their relevancy to other statements. And so we could have our input, Cooper Codes likes pizza, be represented by this huge array that gets created by the OpenAI embedding model. And so you might ask yourself, okay, what does it look like to store these values? Don't get too frightened by this table here, but the basic idea is that we have text right here. For example, Cooper Codes is a YouTuber with 5,000 subscribers. And that text gets represented by an embedding here. So one of the first things we are going to do in this video is we are going to create a PostgreSQL table in Supabase for our embeddings. We are then going to add a method that allows us to get the relevant embeddings. And when I say relevant embeddings, if I were to talk about, who is Cooper Codes, it would grab all of these different embeddings here, all these different pieces of text that are relevant to my initial question, who is Cooper Codes? And then importantly, we are going to take your custom data and turn it into embeddings and then store it in a database just like above. And so guys, I know this is a lot of different steps, but remember, as I go through the code, I'm going to be talking about every single part that you need to understand. All right, so now we're going to go over to Supabase and create everything we need from the PostgreSQL side. Let's get into it. And just a little side note when I get to the Supabase page is that Supabase is officially sponsoring this video. They have announced a bunch of features related to Supabase Launch Week 7, which you can check by going to supabase.com/launchweek. They're doing a bunch of cool stuff, and they're honestly one of my most favorite platforms to work with, and so it's an easy sponsorship for me. So now we can go over to supabase.com and then sign in. You should be initially brought to your projects page, and we are going to press New Project. I'm going to make the name of the project Custom Data Chatbot. All right, guys, this is a super important part of the tutorial. We are going to have to save our Supabase database password because we are going to be using this later in the tutorial. So go over to database password. I'm going to go in here and press generate a password. We can then press copy right here, and then I'm going to copy paste it into my text file. And so make sure not to lose this because we are going to need it later in the video. So keep this around. Once everything else looks good, you can press create new project. The setup portion of this might take a couple minutes, so go hang out or even just watch the beginning of this video again to get a better understanding of the system. So we can get started by going to the left and then going to the SQL editor. From the SQL editor, I'm going to press new query in the top left, and you should be brought to a screen like this. In this video, we are going to be storing vectors because the embeddings give us a vector, like I talked about before. And so vectors are not in PostgreSQL by default. So if we want to enable vectors, we have to say create extension and then a vector with a semicolon at the end, and then you can run that. If it says success, that means you're good to go and you now have vectors enabled. We can then create a table by saying create table documents like this. And it's going to be very simple. We're going to have an ID, which is going to be a big serial primary key. The content is going to have some text. So this is going to be the actual text. For example, who is Cooper Codes might be a document, or, Cooper Codes is X might be a document text, for example. And then we can also add that actual embedding itself. So the embedding is going to be a vector. It's going to have 1,536 different slots in the array. Why 1,536? This is because the specific model we are going to use in this video has that many slots in the array. Put a semicolon at the end, and then we can press run right here. If it says success, then you're good to go. All right, guys, for the next part of this video, we are then going to be copying this code here, which allows us to match documents. This is the specific code which allows us to take a certain query text, for example, who is Cooper Codes, and then return like 5 different documents of information that are relevant to that initial query. And so guys, I would say don't get held up in what this code actually does, as it's not super important for understanding your system. And in the description, there is going to be a paste bin where you can just copy this right here and then bring it over to your editor. We already made the table document, so we can delete this and then paste in our code. Just so you guys see what I'm saying, it should look something like this. And then we can press run, and you'll see it's going to say success, no rows returned, which is great. And so if we go over to our table editor, we should see we have a document that is completely empty, which is exactly what we'd expect. So now one thing we need to do is we need to actually fill up this table with data that is specific to your use case, specific to the information you want. So now we can create some JavaScript code, which is going to take a bunch of text that we are going to supply it with, get the embeddings from the OpenAI API, and then store those text and embedding combos in the database. Just like we had over here, we're going to do the exact same thing. And so before we do any coding, I'm going to get all the different API keys we are going to need for the rest of the video. So we can go over to the home here, and we are going to need the project URL, which we can copy, go over to our text pad and just say project URL is equal to this. And then also the API key here, which we can copy. And it's generally referred to the public anon key, which is just going to be that string right there. We're also going to need an OpenAI API key. What you're going to want to do is you're going to want to go to platform.openai.com. If you don't have an account, it's going to put you through the login process, but eventually you should get to a screen like this. You want to go to your account in the top right, then go to View API Keys right here. We can then say create new secret key. You can name the key if you want, but I'm just going to say create secret key. And we are going to copy this and save it to our text file. So I'm just going to say OpenAI API key is equal to this string right here. These are all the different strings we need. So great job on saving these. Let's get into coding our custom data and turning it into embeddings. To get started, I'm going to create a regular JavaScript project by saying npm init -- yes. This is going to create a package.json, which is important because it's going to allow us to install more packages to our project. For example, I'm going to npm install the @supabase /supabase -js, which is the JavaScript Supabase library, and then also the OpenAI package as well. So next to our package.json, I'm going to create a basic server.js. I'm going to make some comments here to discuss what we're going to do. Firstly, we have to initialize our Supabase client so we can talk to the Supabase client. Then we are going to create a generate embeddings function. Inside of the generate embeddings function, the first thing we're going to do is initialize the OpenAI API, create some custom data. For example, I'm going to be asking questions about Cooper codes. You can do whatever data you want, and then turn each string. So from our custom data, we're going to turn it into strings into an embedding, and then store the embedding and the text in our Supabase database that we just made. This might seem like a lot, guys, but don't worry. We're going to do things one thing at a time. So at the top here, we are going to import create client from Supabase, which is just a simple way for us to initialize our Supabase client. And we're also going to import two things from OpenAI. We're going to import configuration and then the OpenAI API. And so to initialize our Supabase client here, we are going to say const Supabase client is equal to the create client constructor. This constructor here is going to require two different things. The first thing is our project URL, which we have right here. So I'm going to paste it in like this. And then the second thing is going to be our public anon key. So make sure you copy this entire thing and don't miss any characters. And then we can paste that in right here. All right, so now is the fun part. We can actually create our function here. I'm going to say async function, generate embeddings like this. So just a regular JavaScript function, and let's get all of our comments inside of there. We can then initialize the OpenAI API by saying const configuration is equal to new configuration like this. And it's going to take a bunch of different parameters, but we have a relatively simple configuration where all we need to see is the API key is equal to our API key, which we can copy paste from our notepad over here. So just paste it in like this. And guys, you can make these environment variables if you want, but just for the simplicity of this tutorial, I'm keeping things as strings in this part. All right, so now's the fun part is we can create some custom data. So this is the data that you would expect your kind of ChatGPT to respond with. So we can say const documents is equal to, and I'm just going to make it an array of strings. A side note here is if you have PDFs, if you have other, information, I don't know, like websites or something, there are ways to turn those data sources into documents. I'm not discussing that specifically in this tutorial, but just know that you can eventually get those documents into string format. And it's going to follow a very similar process as to what we're going to do here. But that's just a quick side note, and I'm going to delete this comment now. So I'm just going to create some data for ChatGPT to look at. So Cooper Codes is a YouTuber with 5,300 subscribers. And I'm going to say Cooper Codes has a website called coopercodes.com. I'm going to say Cooper Codes likes clam chowder. There you go. And just some final information. I'll say the meta piece of information, which is Cooper Codes has a video covering how to create a custom chatbot with Supabase and the OpenAI API. Yep, so the fourth wall is being broken with this string right here. And so we can do a very simple kind of for each syntax by saying for each document. So const document of documents like this. This is going to allow us to loop through each string. Because remember, what we're going to do now is we're going to make an embedding for each string. To clean up our data in a sense, I'm going to say const input is equal to document.replace. This will replace characters within a string. I wouldn't worry about this too much, but it's pretty much something that I found from an external resource that allows you to replace new lines. And so now we can even take this comment and bring it up here, turn each string into an embedding. We can do that by saying const embedding response is equal to await. Oh, and one thing, guys, is we actually have to initialize OpenAI up here, which I forgot about. But super simple, we can say const OpenAI is equal to new OpenAI API with the configuration we created previously. This object here just allows us to communicate with the OpenAI API through a simple object in JavaScript. So we can say OpenAI dot create embedding like this. Create embedding is super simple. All it asks for is a model. For example, the text-embedding-ada-002. This is the model that creates our embeddings. And then we actually have the input, which we can just say input right here. So the input is the kind of custom data. The model is the embedding, and then the embedding response is how we get, the actual embedding that OpenAI has created for us. Within the embedding response data, it's going to be an array of a bunch of different things. I'm going to gloss over the syntax in a second, but if you want to look specifically into the OpenAI API and how it works, be my guest, of course. But we can get the actual embedding out of this response's data by saying const array syntax and then object syntax embedding is then equal to the response right here. This embedding, as it says right here, is the actual number array. So if you guys remember back in the earlier presentation where we have this embedding array right here, this is the exact same thing that we're getting in the embedding right here. It's that array of numbers. And so now we can use our Supabase client to actually insert these things into our table. So we can say await Supabase client dot from the documents table dot insert, and then it's going to ask us for what data are you trying to insert. Well, we have the content, which is going to be the document. Remember, because the document here is the actual string, and then the embedding, which is going to be equal to the embedding we have at line 29 here. And so this comment could be right here, where we store the embedding and the text in our Supabase database. So guys, if we run this function, what's going to happen, just to cover this again, we are going to configure OpenAI, have our custom documents, and then for each document, we are going to clean the string up a little bit, get the embedding for that specific document right here, and then save the content of that string plus the embedding to our database. And so at the very bottom of our code, we can just run our function by saying generate embeddings like this. And just so you guys know, I'm on Node version 18 because sometimes this node part can be strange. And because I opted to use the import syntax above, one quick thing we're gonna have to do is go over to our package.json, and we want to say that the type of this package is module like this. The module type simply just allows us to use import statements, is kind of all you need to know for this video. And your code's gonna break if you don't have this, so make sure to put this line of code in there. Now in our server.js, we can say node server.js. If you have a lot of data, it might take a long period of time, is something I want to say. You could do a little console.log statement in this for loop to see like which document you're at if you have like thousands, for example. But if that runs with no errors, we can roll over to Supabase. So I'm over on the Supabase homepage. If you go to the left here and go to table editor, we can go to documents here, and we should be able to see the 4 different things that got saved to our actual database, which is great news. And so guys, this is already a super powerful part of the system, is if you ever need any more embeddings, you can do generate embeddings here, create your documents here, and it's going to save them. I will say, be careful not to run this multiple times, because then you're just going to keep on creating new embeddings of the same thing over and over. You only need to run this once. All right, guys, a really interesting part of this video that kind of puts a level up above maybe other videos is that we are going to be using Supabase Edge functions. These are really amazing because we're not just building some rinky dink, like it's about to break in 3 seconds API. We are going to build an edge function that gets distributed globally and is going to be close to your users. So no matter how you end up using this actual endpoint we create, you can have it be, in a chatbot, you can have it be in a, recommendation service, you can have it be anywhere because we are going to call these edge functions here. And the most amazing thing is this super powerful technology is super easy to set up. And just to create a basic idea of what's going to happen is we are going to create an edge function for a certain endpoint. For example, ask-custom-data. This custom data is going to have all of our different logic. For example, the getting relevant documents, the asking ChatGPT, and then returning the response. All that stuff is going to be within this endpoint. And so to set up the edge functions, one thing we have to do is we have to say npm install supabase -- save - dev. This gives us access to the Supabase CLI. So that is the Supabase command line interface. And we can say npx and then Supabase and then init. This is going to initialize some Supabase things locally that allow us to get started with developing Edge functions. And you should get a folder here. You can open up right here. That's going to have some random stuff in there. Don't worry about the random stuff for now. But Supabase has given us some stuff here to now get started with developing these Edge functions. So now we can say npx Supabase login, which means we're going to log in with our account. But for this part of the video, we're not going to have a username and a password. We need to go to this link here, which is app.supabase.com/account/tokens to get an access token. So go to that link. I'm going to generate a new token here. I'm going to call it video token, as I've already created some other ones there. Press generate token. And guys, I would copy this and save it to your notepad. So I'm just going to save it here just in case we might need it in the future. Who knows? There you go. We can go into here, and on Windows, you can just right click to copy your current value in there. So I have it saved to my clipboard, and I can right click. It's going to paste in there, then I can press enter. Finish Supabase login means that we are logged in through the command line, which is pretty cool. We now have to link Supabase to tell it which project we want to talk to. Under your project URL, so right here in your notepad, your project link is this first part of the URL. So make sure you don't copy the dot or the slashes, but it should be the thing that isn't the supabase.co. It should be this thing right here. This is the link or the reference to your project. And so to tell the Supabase command line that we want to talk to that specific project, we're going to say npx Supabase link -- project - ref, and then paste in that value from before, press enter. And guys, you will see why I emphasize the database password so much is we have to go and get the database password now to be able to log in to this specific project. So copy this right here, go down here. You can then right click on Windows. It's not going to show the text this time, but if you right clicked, it's going to be in there. You can then press enter. If it said finish Supabase link, you are good to go and congrats, you're logged in. So inside this Supabase folder in the top left, how you create some functions is you literally just make a folder called functions. Within this folder, you can have a bunch of different folders, but for this video, I'm just going to have one folder and it's going to be called ask-custom-data. Just for simplicity's sake, I'm going to make an underscore shared folder as well. For this video, there's not going to be anything in there, but just so you guys can see the file structure is we have the functions here and then the ask-custom-data is its own folder inside here. This is then going to have an index.ts. Within this index.ts is all the different code we are going to have for this specific endpoint. And so right now we are inside of the ask-custom-data endpoint in our Edge functions. All right, guys, for simplicity's sake, I'm going to put some code in the description. It's going to say initial index.ts code. One thing about Edge functions is they do not support NPM packages. And so you have to get all your packages from external resources. For example, if we copy paste this code over, we can then see that we have all these different packages from hosted links on the internet, which is pretty cool. And it might even teach you guys something who are even more advanced to JavaScript is you can actually import directly from a specific HTTP link, which is pretty interesting. I'm going to do this ts-no check because for this video, I'm kind of pretending that this isn't a TypeScript file, because we're not going to be using any TypeScript functionality. But the reason why I kept it a TypeScript file is because remember, Edge functions have to have a TypeScript file, right? And so to determine the actual logic of our Edge function, so you can imagine like an API endpoint, right? We are going to have the serve function, which comes from a library called Dino, which I wouldn't be too worried about for now. This is going to be asynchronous, and it's going to have a request, which is going to be an arrow function pointing to the logic of this specific endpoint. So right here, we are now starting the ask-custom-data logic. Because this function is like scaling to a bunch of different users, there are some kind of odd things you have to do just for like cleanup sake and to make the code work. For example, for handling some CORS logic, we have to say if the request.method is equal to options, return new response, okay, and then give the CORS headers. I would say don't be too worried about the actual functionality here. For this endpoint, we are expecting it to have a request, and within that request, we are going to have a query, which is going to be our actual question. For example, who is Cooper Codes, right? And so in order to get the query out of that request, we can say const object syntax like this, query is equal to await res request.json. So that's going to get the request, put it into a JSON format, and then allow us to get the query property out of it. which is then going to give us the string who is Cooper Codes. Similar to before, we are going to clean our input by saying const input is equal to query.replace the new line syntax with a G at the end, pretty much replacing all of the new lines with an empty space. And so we can make our lives a bit easier now by going over to the server.js, scrolling up to the top here, and then copying our configuration code for OpenAI right here. Go back to index.ts and we can just paste it in, because you'll see at the top, we've already imported these two different things here. And so guys, now we're really going to get into the meat of the code here. So what do we have to do? Well, first things first, we have to create an embedding for our question/input. And just to explain why do we have to create an embedding for our question or input, it's because remember this graph from before. We are going to create the embedding for who is Cooper Codes, and then we are going to use the match documents code to allow us to see the information that's relevant to that question. So in order to see where that question lands next to all of our other information, we have to create the embedding. And so before we do the actual embedding, I'm just going to make comments for the rest of our code so we're all on the same page. The next thing we're going to do is we're going to get the relevant documents to our question by using the match_documents function. This is what we copy pasted in at the very beginning of the video, and I'll get into it some more when we actually do this part of the code. We are then going to loop through the relevant documents and format them for the ChatGPT prompt. We are then going to create the actual prompt, which is going to have the system statement, so how the actual ChatGPT should act, the actual relevant documents, and then at the very end, the most important part, our question. We are then going to get the response from the text DaVinci 003 model, and then finally we are going to return the response from the model to our user through a response. So this is like if you were to call the endpoint, you would imagine I call the endpoint, all this logic happens at the very end, it responds back to me with my expected result. Just for example's sake, an idea of what the response would look like is something like this, where it shows the text for, yes, Cooper Codes has a website called coopercodes.com. All right, well, let's get into it. The first things first here at line 27 is, guys, we don't even need to code anymore. We can go back over to server.js and we can copy this embedding response right here that we made around line 24. It's going to be inside of your for loop over in server.js. We can go to index.ts here, and this is going to be the exact same thing. Our input is already formatted as input, and we're using the exact same embedding model. And so now we want to get the relevant documents to our question by using the match_documents. And so guys, just to use this example here again, is what match_documents is doing is it's kind of doing this logic here, where we have who is Cooper Codes, and we want to see what information is this string closest to. Match documents is taking the who is Cooper Codes and it's finding the closest documents next to it kind of in like the vector space, if you could imagine. Like this is 2D, so we only have the X and the Y axis, right? And so who is Cooper Codes might be placed over here. Then it's going to be like, okay, what are our matches? Well, we're matched to here, we're matched to here, and we're matched to here. That's what it's doing. And because it's a function that we created in Supabase, it's going to be going through something called RPC. RPC is a simple way for us to call PostgreSQL functions in Supabase. But now that we actually have to use Supabase, one thing we have to do is go over to our server.js, go to the top where we initialize Supabase, copy this right here, and bring it over to the top right here above your serve function. And it's important that your Supabase client is above the serve function because you don't want to initialize the client on every single API call, right? That would be a little bit crazy. Oh, and one thing is we actually need to get the embedding out of this embedding response. We can use the exact same syntax that we used over here. So I'm just going to copy it over from our other file and then paste it in here. It's the exact same API call, so it's going to be the exact same response. And so we can get the embedding out the same exact way. Now we have everything we need. We can go into here and say await Supabase client.rpc. The name of our function is match_documents. And then it's going to take in an object, which is all the different parameters it needs to run this specific PostgreSQL function. For example, the query_embedding is going to be equal to the embedding that we have above. We can then use the match_threshold. This is just a threshold for what data means that it's close to your initial data. I'm just going to use what I saw in a blog post earlier, which was 0.73. You can change this around and see how it changes what documents actually match, but I'm just going to use this for now. Match_count is way more simple. It's pretty much the number of matches that you're allowed to have. For example, do you want to have 10 documents of data or do you want to have 1,000 documents of data? keep in mind that if you have a very large data set and you give it 1,000 different documents and then you put that into your ChatGPT request, first of all, it might not run at all. Second of all, is it's going to be very expensive. So I'm keeping the match count relatively low for this video. And so to get some data out of this RPC call, once it's done, we can say const and then use an object syntax like this is equal to the await statement. We can then get the data and then the error object out of this call. So RPC is eventually going to return a data or an error object. The data object I'm going to return as a named documents like this, which is just a syntax in JavaScript. And so if you get an error here, you can just say throw error. So the error handling is actually super simple for the Edge functions. And so for looping through the relevant documents and formatting them for the prompt, one thing I'm going to do is I'm going to make sure to limit the token count to 1,500. This is so our bank accounts don't completely blow up and we try to buy some API requests that's very expensive, right? And we get access to this thing called the GPT-3 tokenizer. I'm going to make the type be equal to GPT-3. This is pretty much how many tokens does a certain string turn into. I don't know if this is true, but Cooper, for example, might be represented by 3 tokens. And so we can use these little calculations to kind of see what our API call is going to cost before we actually do it. And so we can say const tokenizer is equal to GPT-3 tokenizer. Let the token count be equal to 0. Let the context text be equal to an empty string. And so this is all of the documents together. So as we loop through the actual documents right here, we are going to be making one huge text string that they can all be a part of. And so I'm going to use some simple for loop syntax by saying for let index equals 0, while the index is less than documents.length index plus plus. So loop through those documents. And just to explain one more thing, documents is going to look like an array of strings. So for example, I might have the first document like Cooper codes is a programmer, or your membership doesn't allow that feature. I don't know what you guys are building with this, but just an example of maybe something that's not this Cooper code stuff. And so to get the actual text of a certain document, it's going to be const document is equal to documents of I. We can get the content of a certain document by saying const content is equal to document.content. And then const encoded is equal to tokenizer.encode the specific content. And so this is going to give us an encoded text, which is going to represent how many tokens does the initial document text cost. So we can say token count, the counter that's tracking these things happening overall, plus equals encoded.text.length. We are going to break our loop by pretty much saying that's too expensive, don't include this information in the end result. But if we are at a good amount of tokens, what we can do here is we can say the context text plus equals. I'm going to use some syntax here with backticks that allows us to do something called content.trim. So we can say $, some object syntax like this, and then content.trim. Trim takes away spaces from the front and the end of a specific string. And then we're going to add some dashes to the end of each specific piece of information, and then a \n for a new line. This means that all of our data is going to be formatted in a way where each piece of new information is on its new line with a couple of dashes at the end of it. So an example of what might happen here is we are going to have our context text at the end here, and it's going to look something like this. And then your membership doesn't allow that feature. --\n. And so this is the information that's going to eventually get passed to our prompt. And so you guys can see how this allows us to create ChatGPT with custom data is within our prompt. And so this is the prompt that we are going to send directly to the DaVinci 3 model right here. And so we can just kind of start create the prompt here by saying const prompt is equal to, I'm going to use something called strip indent. And then I'm also going to include this thing called one line. This one line is going to allow us to create a statement at the top of our thing here that's in one line, but we can still have multiple lines inside of our text editor. It's kind of just to help us out, so don't get too confused by it, but this is the syntax initially. So inside of here, we kind of have the system prompt. So for my use case, I'm going to say you are a representative. That is very helpful when it comes to talking about Cooper codes. Only ever answer truthfully and be as helpful as you can. So you can just say kind of whatever statement you want there, and that's going to be at the top. Now, under that statement, we can have our context sections like this, which we can just do a simple $, object syntax, context, text, which is going to be this text that we have right here. So just like I set up here, we're going to have the system statement, which is right here. We're going to have the relevant documents, which are right here. And then the question at the very, very end, which is going to have 3 different strings around it like this. And that question is being stored in the query, which we have right here. It's coming from who is Cooper codes. If you guys are kind of confused as to where's the query variable coming from, it's coming from right here. It's going to say who is Cooper codes. And then at the very end, I'm going to ask it to answer as simple text. You can also ask it to, respond as a JSON or respond as kind of whatever you want. Respond is like markdown. But for this example, I'm just going to do simple text to make it the easiest. And I believe I can also just indent these all right there, but this is a stylistic choice. Don't worry about that. But now we have our entire prompt, which is really great stuff. And so now we can get our response from the TextDaVinci 3 model. We can say const completion response because we are going to get a text completion from await OpenAI.create completion. The create completion allows us to use models like TextDaVinci 3. And so it's going to have a model property that's equal to text-davinci-3 like this. We are then going to pass in the prompt we made at line 74 by just saying prompt like this. The max underscore tokens is going to be equal to 512. You can change this to however you want. And then the temperature is going to be equal to 0. If you don't know about these 2 properties at the bottom, I wouldn't worry about it too much. Temperature at 0 is kind of known to make it be very rigid in how it talks to you. It's not going to be very random. It's going to be these are the facts. But you can mess with the actual temperature and see how it changes for your results if you like. All right, so now we still have to actually get the response. So we have the entire completion response right here, but inside of the .data property is where we're going to find our actual data from the completion response. And so we can say const ID, choices, and then get this array of text right here. Choices is an array inside the completion response, and then the text property is the thing that we're grabbing out of it. This is kind of confusing syntax if you're a beginner, but I would say don't worry about it too much. Even though we just did a bunch of code, we are still in an API endpoint. And so at the very end, it's kind of expecting us to return a response. So we're going to return a new response object. This response object is going to have a body initially, and it's going to be a JSON.stringify, an object with the ID, and also the text. And so what this is going to do is it's going to allow us to respond in a way that's similar to this object here. We are going to have the specific ID of the completion, and we're also going to have the text that's giving us in the second property here. We can then add a second parameter here to initialize some specific properties about our response. For example, our headers in the response is going to have all of the different cores headers. And so I'm going to say ... cores headers. And then the content -type is going to be of application/JSON. All right, guys, that was a lot of code. And if you made it to the end, I just want to say thank you so much. You should 100% subscribe if you like staying with me for this much. But, do what you want, of course. But now we can actually deploy this endpoint to be called from anywhere, which is super cool. And so Supabase almost makes this too easy. We've already done all the different authentication in our terminal. And so if we go back into the terminal, we can say npx Supabase functions. And as long as your functions folder is exactly like I have it here, all you have to say is functions deploy, and then the name of your route you want to deploy. So for example, ask-custom-data. And we can press enter here, and you should see that we've deployed the function ask custom data on this specific project. And then it even gives us a link to go to. So I'm going to hop over there right now. So our function is up and running, but now we're going to make a very simple way just to call the function and test out our logic. So I'm going to go back over to our server.js, and I'm going to make sure to delete the generate embeddings, just a little function call at the end. Inside of server.js, I'm just going to get access to our Supabase client and make a very simple function call. So I'm going to say async function ask question, and I'm going to make a very simple await Supabase client dot functions dot invoke. Now we can ask for a specific function name, for example, ask-custom-data, and then we are going to give it a body here. So the body is going to be JSON.stringify, an object, and remember, what should our object have? It should have a query property, which is what we discussed before. And so now I'm going to ask the classic question, does Cooper Codes have a website? So you can imagine if I had a front end for this on my own website and someone was talking to a chatbot, I could respond to them with an answer from this API. And so to get the actual data from this response, I'm going to say const data is equal to await Supabase client like this. And I'm just going to console.log the data at the bottom here. And then I'm going to call the ask question code right here. And make sure that you've deleted your little function call for generate embeddings, or else you're going to generate embeddings and ask a question. So watch out for that. And we're in the same spot we were previously inside of our command line. So we can just go to node server.js, just like we did before. All right, so our node server.js is going to return us that text coming from our API. And for the record, I was using the wrong Supabase link at the very top here for a while. And so if stuff like that breaks in your application, try and make sure that all of your different client IDs, your URLs are all correct. And honestly, for the future of this, I'd probably use environment variables or something like that. I say all that because you can see out my 500 errors because I was calling Supabase correctly, but my internal Supabase was using the wrong link, so it was breaking internally. But as you can see, we're getting a bunch of 200 requests now, and we can ask our custom data any question we want. So for example, it says that I have a website named Cooper Codes. I'm wondering what it's going to say if I ask who is Cooper Codes. So we can ask that, save our server.js and run it again. Yo, it knows me too well. It says Cooper Codes is a YouTuber with 5,300 subscribers who creates videos about coding and technology. He also likes clam chowder. That's a pretty good summarization of myself. This is just a simple Q&A bot, so it's not going to have the answer to have like a long conversational chain, for example. But if you guys are interested in this type of content, make sure to subscribe, and I'll definitely have more stuff in the future. I'll ask one more question because it's kind of like an anticlimactic ending, but it's just the project done. But I'll ask, what is Cooper Code's favorite food? You can see that this project gets way more interesting when you ask it like real questions. We're talking about like, customer service applications, any really AI application that requires some type of custom data is going to be very applicable to this use case. And of course, it says Cooper Code's favorite food is clam chowder. And so this is really interesting stuff because ChatGPT generally doesn't know anything about my channel, as I talked about before. And so it's really cool to see how we can add on our own data on top of this and kind of get an introduction to embeddings and also understanding how to create an API that scales. All right, thanks so much for watching.